In this video, we'll get to talk about trigonometry and some of its uses. Before we get to any of the uses, let's talk about what trigonometry is. Trigonometry is all about the relationship between the angles of a triangle and the sides, and how we can use one to find the other, or two to find the other. Now, when we think of trigonometry, first we apply it to right triangles. These are the ones that we talk about the most. This is the one where the trigonometry is the easiest to apply. First, on our right triangle, we need to pick an angle that we're going to use as kind of like our target angle. It doesn't really matter which one we pick so long as it's not the 90. Let's pick this one. We'll call it something. We'll use a Greek letter. We'll call it theta. You can call it whatever you want, but this is the letter that we'll use. Okay, if I think about it, opposite this angle is what we're going to call the opposite side. Okay, the one right here on the bottom is what we're going to call the adjacent side, meaning that it's right next to the angle, it's containing this part. The adjacent is right next to our target angle, so to speak. And then the big side, the one across from the 90, is what they call the hypotenuse. Now, if I think about it, it would make sense that if theta changes, these other sides should change as well. In particular, if I change theta, the opposite side will change. If I change theta, the adjacent side will change. If I change theta, the hypotenuse will change. All these sides will change. Then likewise, if I change the sides, that should also affect both of my angles. So we use trigonometry to kind of describe this relationship. If I look at the three trigonometric ratios, the first one we'll talk about is sine. Okay, that's how we spell it. In mathematics, we abbreviate it SIN. So sine of theta. Now, sine's a function, so sine of theta, meaning I did something to theta, is going to equal the opposite side over the adjacent, or over the hypotenuse. Okay, likewise, we'll have cosine. And cosine is going to be abbreviated COS. So cosine of theta is going to be equal to my adjacent side over my hypotenuse. And then likewise, the last one is what we call tangent. Now tangent is abbreviated TAN. So tangent of theta is going to be equal to my opposite over my adjacent. Now there is a little mnemonic you can use to kind of help yourself remember which one goes to which. So if I'm looking at sine, sine is equal to opposite over hypotenuse, or so. Cosine is equal to adjacent over hypotenuse, ca, and then tangent is equal to opposite over adjacent. So altogether you have so, ca, toa. It's a way to kind of remember which one goes to where, which sides apply to which ratio. Now that we've talked about each of the trigonometric ratios, let's actually see them in action. So what we've got here is we've got a right triangle. We know one of the angles is 30 degrees, and we know that the hypotenuse is 4. We could use special triangles here, but for the sake of the sake, let's apply trigonometry to this. That way we can see it in action. So if we think about it, we know the hypotenuse. If I go back to my little mnemonic, I have SOHCA TOA. Now, if I'm going to solve for x and y, I'm going to need to use ones that involve the hypotenuse. So tangent is not going to help me here. That means it's one of these two. So I'm looking at it, I got to pick one. So let's say we solve for x first. Okay, x is going to be opposite of the 30. And then likewise the y would be adjacent to the 30. So first off, let's solve for x. So sine of 30 degrees has to equal x over 4. Now at this point, I could run to my calculator, I could get a value for sine of 30. Totally could do that. It's just a number. It looks weird, but it's just a number. So if it's just a number, I should be able to multiply both sides by 4 to eliminate the 4 underneath the x there. So this would tell me that 4 times the sine of 30 degrees is going to be equal to x. Now at this point I would run to my calculator, make sure that I'm in degree mode if that's a problem. On a TI-84, that's what you'll have to do, is set it to degree mode. Once you punch all this into your calculator just as you see it here, you'll get x has to equal 2. Now we can solve for y in a very similar fashion. If I'm looking at y, that's the adjacent side. That would tell me I have to use cosine. So if I'm going to use cosine, I'd say cosine of 30 degrees, again the angle, is equal to y, my adjacent side, divided by 4, my hypotenuse. Now just like I did with the x, cosine of 30 is just a number. I could run to my calculator and get a number for it. I multiply both sides by 4 to eliminate the 4's on the right side. So then y has to equal 4 times the cosine of 30 degrees. Now again, I run to my calculator, I can punch that in, and if I do that, I will get roughly 3.46. Okay, now that would be the lengths of the sides. You can use your angle and one side to figure out the other two. That's the benefit of trigonometry in this case. But you can also use it, if you know some of the sides, you can figure out the angles. So let's look at a case where we have to find the angle size. We're given all 3 side lengths here. Okay, and let's say, for the sake of the sake, let's solve for theta first. Okay, so if I'm looking at this, we'll write our mnemonic up here. SOHCAHTOA. I have the benefit of knowing all 3 sides. So the cool part is here, I can use whichever one I want. For the sake of the argument, I will use all 3 just to kind of show you that they're all the same and that either one you choose will work. But if you're only given 2 sides, make sure you pick the 2 that you have. So like say I only had 3 and 4, that would be the opposite and the adjacent, which would mean I would have to use tangent. So let's go ahead and run with that example. Let's say I use the 3 and the 4. So that would mean that tangent of theta has to equal my opposite, 3, divided by my adjacent, 4. Now, right here, I have to somehow find a way to get tangent off of this side, to get theta all by itself. There is a button on your calculator that allows you to do that. It's called tangent inverse. So what you'll essentially do is you'll take tangent inverse of both sides. And that will essentially look like this. Then you'll do it to the other side as well. So that would mean that since this is what undoes tangent, these in essence cancel out, leaving you just theta on this side. So theta is going to equal tangent inverse of 3 divided by 4. Now, you can run to your calculator, make sure you're in degree mode if you want degrees. So you'd hit tangent inverse of 3 divided by 4, and you'll get theta is roughly 36.87 degrees. Now, I could use this same line of thinking, but use a different trigonometric ratio, and I'll get the same thing. I'll show you a couple examples here. Let's say I wanted to use cosine. So cosine involves adjacent and hypotenuse. So I could say cosine of theta is equal to my adjacent, 4, divided by my hypotenuse, 5. Now for the same logic, I can apply cosine inverse just as the same way I did tangent inverse. So this would mean that, in essence, my cosine would cancel, leaving me just theta has to equal cosine inverse of 4/5. If I punch that into my calculator, I will get the same thing. I'll get the 36.87 degrees. Okay, I can do the same thing with sine. So if I go over here, I can do sine of theta, and that has to equal my opposite, which is 3, divided by my hypotenuse, which is 5. And again, I can say theta has to equal sine inverse of 3/5. Okay, run to your calculator, punch that in, and you'll get the same thing as you have the other two. So you get theta is roughly 36.87. Okay, so I've shown you 3 ways. In this case, since we know all 3 sides, we can use all of that to our advantage. Now, if I wanted to solve for alpha, I could apply the same logic and solve for it just in a slightly different way. So, for the sake of the sake, I'll just solve one way, just to show you in practice what it would look like. So if I'm looking at alpha, if I look at my triangle, what this would mean is that alpha is now my angle that I'm looking at, that would make 3 my adjacent, it's going to make 4 my opposite, and it's going to keep 5 as the hypotenuse. That one doesn't change. Okay, now if I solve for it, let's go ahead and use sine. So if I recreate my triangle here, this being alpha, okay, so if I use sine, that's going to be opposite over hypotenuse. Remember our mnemonic. So, for sine. So sine of alpha is going to be equal to 4 over 5. And again, I just do sine inverse of both sides, in essence canceling out the sine and sine inverse on the left side, leaving me with sine inverse of 4/5 on the right side. I run to my calculator, make sure I'm in degree mode. So sine inverse of 4 divided by 5 is going to be equal to roughly 53.13 degrees. Now, that just shows us one example of how we can use our side lengths to determine our angles, and how we can use our side lengths or our angles to determine our side lengths. You can use trigonometry on right triangles, go both ways. It's incredibly useful, it's very applicable. You can use this just about anywhere in construction, welding, engineering. It pops up all over the place. Hope this video is of use to you, and good luck.